Hello viewers, and welcome once again to my YouTube channel. In our today's class, we are going to consider this equation: 4 raised power of 2 raised power of x is now equals to 2 raised power of minus x. So follow me, let's solve this particular equation together. So let's get started. Solution: 4 squared raised power of x is now equals 2 raised power of negative x. But we know that we can actually raise 2 to the power of 2 to give us 4. So this is the same thing as 2 squared raised power of 2 raised power of x is now equals 2 raised power of negative x. And I know that whenever I have x raised power of m multiplying n, whatever the value of this n may be an exponent. So to be is the same thing as x raised power of n. So going by that, that means I can have 2 raised power of 1 multiplying 2 raised power of x to be equals 2 raised power of negative x. And I can see that these two bases are the same. I can equate the powers. So the powers are 2 raised power of 1 multiplying 2 raised power of x to be equals minus x. Let me divide the both. So at this point, I want to divide both sides by 2 raised power of x so that I have a concentration of my unknown in one side, so that I have minus x over 2 raised power of x is equals 2. I don't want to deal with negative sign from the side of my unknown. So I want to take this negative sign to the right hand side. That means I need to divide both sides by minus 1. So I will have x over 2 raised power of x is now equals negative 2. So when we consider this, if I cross multiply, I will get to understand that this x will be a base, and here is a base. When we consider the nature of the question, we will get to understand that we have our unknown at the base, we have it at the exponent. And in that case, we should start thinking, it's not all the cases, but in majority of cases, it leads us to Lambert W function. So we need to at least start preparing ourselves on how to get started when it comes to Lambert W function. So this x divided by 2 raised power of x, I can as well change the division to multiplication. That means I need to take the reciprocal of this x. That means I will now have x multiplying 2 raised power of negative x to be equals minus 2, because I changed the division to multiplication. Now, this 2 raised power of minus x, I can write it as a function of e, or function of Lambert W function. That means if I put e raised power of ln of a is the same thing as a, because ln and e cancels each other. So going by this, I can write this as x multiplying e raised power of ln of 2 raised power of minus x to be equals minus 2. Don't mind my equality sign to be equals, I didn't change anything because ln and e crosses each other. It's just like a square root and to the power of 1. Square root and power of 1 over 2 cancels each other, so it does the same thing here. So we know that if we have a certain functions or group of functions or bunch of functions or variables, when we input them into Lambert W function, this is what it does. When I have e, for example, I have stuff here, I must have the same stuff here. when I put this into Lambert W, I'm definitely going to get the same answer. That means, that is to tell you that whatever that is here and whatever that is here must be the same. So what I'm saying in a short note is that the content of this place and the content of this place must be the same. I must make this and this to be the same. So how can we now make this and this to be the same? So we know that according to the law of logarithm, this minus x can actually come here to multiply ln of 2. So here I will have x multiplying e raised power of minus x ln of 2 to be equals minus 2. So I have ln of 2 here. I don't have ln of 2 here. That means I need to multiply both sides by ln of 2 so that I have ln of 2 here. Then I have negative here. I don't have negative here. That means I need to multiply both sides by ln minus ln of 2. So in multiplying by minus ln of 2, here I have minus x ln of 2 multiplying e raised power of minus x ln of 2 to be equals, since I multiplied here by minus ln of 2, here I will still have to multiply by minus ln of 2, but the negative here will have to cancel. So here I'll have 2 multiplying ln of 2. As simple as that. And this is a very good point of bringing in our Lambert W function. I mean, this is where our Lambert W function comes into play. So we try to input everything here into our Lambert W function, because whatever that is here and whatever that is here, we can see that is the same. So when we input this, we are going to have W bracket open x ln of 2 multiplying e raised power of minus x ln of 2 is now equals to ln of 2. So sorry, my brain skipped something. I made a mistake. 2 ln of 2. So going by this, we can see that whatever that is here, we can see that this is x, and to be equals to, this is a star, not x, this is a star, and this is a star. That means whatever that is here is equal to, I can pick either this or this, although they are the same. So minus x ln of 2 is now equals w bracket open 2 ln of 2. So I'm looking for x. That means I need to divide both sides by minus ln of 2. So my x is now going to be minus w bracket open 2 ln of 2 everything over ln of 2. This is your answer to this particular equation. But if you have your calculator or any computing machine that supports Lambert W function, at the end of everything, you are likely to have x is equals to minus 1. Yes, minus 1. That is approximately. That is x is approximately minus 1. And this is all I have for you for today, my viewers. If you have any observation, you notice an error, don't hesitate to let me draw my attention in the comment section. Don't forget to subscribe to my YouTube channel for more exciting content like this and many more. Bye.